Hello students, today in this video we'll see the rules for tracing of Cartesian curves which are given by the explicit relations. In the previous video we have seen a few definitions related to curve tracing. Now the rules. The first rule is the symmetry. In that we have symmetry about the x-axis. In the given equation, if all the powers of y are even, then the curve is symmetric about the x-axis. We can see with an example, y square is equal to 4ax. The power of y is 2, that is even. That means the curve is symmetric about x-axis. We know it is the standard parabola. Then symmetric about the y-axis. In the given equation, if all the powers of x are even, then the curve is symmetric about the y-axis. Like we'll see, if x square is equal to 4ay, the power of x is 2. Okay, it is even. That means the curve is symmetric about the y-axis. We know it is a parabola. Okay. Then the third one, symmetric to both x and y axis. In the previous case, they were either symmetric to x axis or y axis. Now to both the axes. In the given equation, if all the powers of both x and y are even, then the curve is symmetric about both x and y axis. We'll see with the help of an example. X square plus y square is equal to a square. Now here the power of x is 2, it is even. The power of y is also 2, which is even. That means the given curve is symmetric about both the x and y axis. We know this is a circle whose center is at the origin and it's symmetric about both the x axis and y axis. We'll see another example. X square upon a square plus y square upon b square is equal to 1. Here also the power of x is 2, which is even, and the power of y is 2, which is even. Okay, so the given curve, it is symmetric about both the x-axis and y-axis. We know this is the ellipse. Okay, so this was the first point regarding the symmetry. The next rule, it comes about the points of intersection. Now first we have to see whether the curve passes through the origin. To find out that, we'll put x is equal to 0 and y is equal to 0 in the given equation. If we get 0 is equal to 0, or if the given equation is free from absolute constant terms, then the curve passes through the origin. So substitute x is equal to 0 and y is equal to 0 in the given equation and see what you get. If it is 0 is equal to 0, that means the curve passes through the origin. Then we have to find the intersection of the curve with the x-axis and the y-axis. And these points of intersection of the curve with the coordinate axis, they are known as the special points. First we'll see for x-axis. We'll put y is equal to 0 in the given equation. And we'll find the values of x. And for y-axis, we'll put x is equal to 0 in the given equation and we'll find the corresponding values of y. In this way, we can find out the points of intersection of the curve with the coordinate axis. Now, the tangents. First, the tangent at the origin. Now, if the curve is passing through the origin, we have to find out the tangent at the origin. Now, how to find that? To find the tangent at the origin, equate to 0. Lowest degree term taken together. That means, now suppose this is the equation of the curve y square into bracket 2a minus x is equal to x cube. We solve this bracket and we have 2ay square minus xy square. We'll take this x cube on left hand side. We have minus x cube is equal to 0. Now what is said? The lowest degree term. Now the lowest degree term in this equation is what? We have here the degree of y is 2. For this term the degree will be 3, and for this also it is 3. So the lowest degree term is this 2ay square. So we'll equate this 2ay square is equal to 0. Now 2a is a constant, it can't be 0, so y square is equal to 0, which implies y is equal to 0. So y is equal to 0 is a tangent to the curve at the origin, and y is equal to 0 is nothing but the x-axis. So x-axis is a tangent at the origin. Now next, we have found out the special points, that is the points of intersection of the curve with the coordinate axis. These points are known as the special points. Now differentiate the given equation with respect to x. That is, we have to find dy by dx. Now let a and b be any point other than origin. Okay. So what we have to do? We have to find the value of this dy by dx, which we have found out at the points a and b. Now if the value of dy by dx at AB is equal to 0, then at the point AB, these are the coordinates of the point, at AB the tangent is parallel to x-axis. If the value of dy by dx at AB is equal to plus minus infinity, then at AB the tangent is parallel to y-axis. That means if the value of dy by dx at AB is 0, the tangent is parallel to x-axis. And if the value is plus minus infinity, then at AB the tangent is parallel to y-axis. The third condition, if the value of dy by dx at AB is equal to positive, that is, if we get a positive value, then the tangent makes acute angle with the x-axis. And if dy by dx at AB is negative, then the tangent makes obtuse angle with x-axis. Okay, we have to consider these points. Now the next rule, asymptotes. All of you know asymptotes are tangents to the curve at infinity. Now how to find the asymptotes to the curve? First, asymptotes parallel to x-axis. How they are obtained? They are obtained by equating to 0 the coefficient of highest degree term in x of the given equation. That is, in the given equation of the curve, we have to see which is the highest degree term in x, and we have to equate the coefficient of that term to 0. And to find asymptote parallel to y-axis, how it is obtained? It's obtained by equating to 0 the highest degree term coefficient of y in the given equation. So now to find an asymptote parallel to y-axis, the coefficient of highest degree term in y, we have to equate that to 0. We'll see with an example. If we have xy square is equal to a square into x plus a, which implies we'll solve this. Xy square is a square x plus a cube, or x into y square minus a square minus a cube is 0. Now, if we are to find an asymptote parallel to x-axis, coefficient of highest degree term in x. Now in this, the highest degree term in x is this, and coefficient of x is what? Y square minus a square. So we'll equate this term y square minus a square to 0. So y square minus a square is 0, which implies y is equal to plus minus a. That is, y is equal to plus minus a. They are the asymptotes parallel to x-axis. Now, to find the asymptote parallel to y-axis, what we have to do? We have to equate to 0 the coefficient of highest degree term in y. which is the highest degree term? It is this xy square. So this y square, this is the highest term in y. So what is the coefficient of y square? It is x. So we are equating to 0 the coefficient of y square, that is x is equal to 0. It is an asymptote parallel to y-axis. Okay. And the last one, we have to find the region of absence of the curve. That is, we have to find the region where the curve doesn't exist. Now how to find that? If the given curve it is symmetric about x-axis, then what we'll do, we'll express the equation in terms of y square is equal to f of x and check how y varies as x varies. We can find some values of x where y square becomes negative, which is not possible. Hence, the curve doesn't exist in that region. That means, suppose we have y square is equal to 4x. If x is negative, what will be the value of y square? It will be negative. It will be less than 0. And so, the curve doesn't exist in that region. That is, the curve doesn't exist for x is less than 0. So for all the values of x less than 0, the value of y square will be negative and hence the curve doesn't exist in that region. Similarly, if the given curve it is symmetric about y-axis, express the equation as x square is equal to f of y. And then we can find some values of y where x square becomes negative, which is not possible. Hence, the curve doesn't exist in that region. Like if we have x square is equal to 2y. If y is less than 0, that is if y has got a negative value, the value of x square will also be negative. That is x square will be less than 0 and the curve doesn't exist in that region. That is for y less than 0, the curve doesn't exist. So these were the basic rules for curve tracing. We'll see in short what we have to do. First, we have to find the symmetry of the curve. Then we have to find the points of intersection. That is whether the curve passes through the origin, and then the points of intersection of the curve with the coordinate axis. Then we have to find the equation of tangent at origin and at the points of intersection. Then we have to find the equation of asymptotes. Then we have to find the region of absence of curve. And last, we have to trace a rough sketch of the given curve with all these parameters.